Okay, so now with our knowledge of the probability current, which we can write as J H over 2mi times psi star del, the gradient of psi minus psi times the gradient of psi star, we can actually solve now exercise 5.3.2 in Shankar's textbook. So in this particular problem, it says given a wave function psi, which I can write as a constant c times a wave function psi tilde, where c can be either real or complex, but psi tilde is only real. So if this is the case, then J should equal 0. So let's do that. So let's start with this equation above, and we'll plug in the various components and see what we get for the probability current. So in this case, I already wrote down that psi is C times psi tilde. Psi star is C star, in case the coefficient is complex, times psi tilde. And psi tilde is real, so it's not, it doesn't have a complex nature to it. Okay, so let's put that into the equation. So J is equal to H bar over 2mi C star psi tilde, the gradient of C psi, minus C psi tilde, the gradient of C star psi tilde. Okay, so now all of the psi's have become psi tildes. So we can factor out the coefficients, C star, and what we're left with is psi tilde, the gradient of psi tilde, minus psi tilde, the gradient of psi tilde, which is basically equal to 0. So what we're left with is H bar 2mi C star times 0. So our current is basically 0. So a pretty simple exercise, but showing that if the wave function is just real and what makes it complex is just a coefficient that you multiply times the wave function, then in the end the probability current is just 0.